Hello and welcome. Today we are discussing a practical solution to a common industrial problem: how to reinforce epoxy resins without losing their insulating properties. We will look at how a specific material, known as onion-like graphene, makes these composites significantly stronger and more durable. Let's get straight to the facts. Epoxy resins are the invisible foundation of modern industry. They are used to create high-strength composites, protective coatings, and components designed for extreme loads. However, even the most reliable epoxy systems have a major vulnerability. After full curing, the polymer matrix becomes rigid and quite brittle. Under cyclic and impact loads, microcracks inevitably form within the structure. Furthermore, intense sunlight can heat the material up to 60 to 80 degrees Celsius, causing the epoxy base to rapidly lose its stiffness and strength. For a long time, research centers attempted to solve this problem using various nanomaterials. While these additives can significantly increase a composite's strength, scientists faced a critical obstacle. That obstacle is the extremely high electrical conductivity of carbon fillers. Standard reinforcing nanoadditives form a continuous conductive network at extremely low concentrations. If this barrier is exceeded even slightly, the polymer instantly transforms from an electrical insulator into a conductor. Because of this limitation, safe and minimal dosages only yield a strength increase of 2 to 15%. Additionally, during manufacturing processes like filament winding, traditional nanomaterials align along the fibers, creating dangerous local paths for current leakage. For a long time, reinforcing a polymer without losing its insulating properties seemed impossible. A solution emerged with the development of a unique nanomaterial known as onion-like graphene. This material bridges the gap between fundamental science and large-scale manufacturing. Onion-like graphene consists of ultra-pure carbon nanoparticles with a unique spherical shape. Their diameter is microscopic, between 20 and 60 nanometers. The structure consists of 40 to 60 concentric carbon layers perfectly nested inside one another. Unlike conventional laboratory analogs, this product features exceptionally high industrial purity, containing no diamond core or residual metallic impurities. The spherical nature of onion-like graphene completely eliminates the risk of short circuits. The round nanoparticles distribute evenly throughout the resin and do not chain together to form conductive paths. This allows manufacturers to introduce an effective concentration of the filler, making the material ultra-strong while preserving its excellent dielectric properties. Integrating onion-like graphene fundamentally changes the mechanical and physical properties of the epoxy matrix. First, it alters the material's mechanics. At the nanoscale, the carbon spheres act as structural barriers. They redistribute internal stresses, stop microcracks from growing, and deflect their trajectory. As a result, the composite gains outstanding fatigue resistance, fracture toughness, and resilience to severe impacts. Second, it provides exceptional thermal stability. The introduction of these particles increases the thermal conductivity of the epoxy resin by more than 3 times. The indicator rises by 320%, reaching 0.59 watts per meter Kelvin. Heat from solar exposure or electrical loads is instantly and evenly distributed across the entire thickness of the product, eliminating dangerous localized overheating. Third, it offers built-in ultraviolet protection. Onion-like graphene highly absorbs light in the ultraviolet range. The nanospheres dispersed in the resin create a stable shield that radically slows down photodegradation, yellowing, and surface erosion under the sun. Where exactly are these enhanced epoxy resins applied? The possibilities are extensive, because the modified material is now ultra-strong, thermally stable, and completely insulating. It is highly effective for manufacturing heavy-duty utility poles that can withstand extreme weather and physical impacts. It is also ideal for creating advanced insulation systems for high-voltage power grids, ensuring absolute safety and reliability. Furthermore, this robust polymer matrix is perfectly suited for casting reliable protective components for sensitive electronics, shielding them from environmental stress and mechanical damage, without any risk of short circuits. For a long time, the widespread application of onion-like graphene was hindered by the high cost of its synthesis. Older technologies were fundamentally unsuitable for large-scale production. The scalability issue was resolved by transitioning to the method of pyrolysis. Precise control of thermochemical processes drastically reduced synthesis costs. To summarize, onion-like graphene effectively transforms brittle epoxy matrices into highly durable, thermally stable, and ultraviolet-resistant composites. Thanks to this technology, the advanced modification of polymer matrices has officially transitioned from resource-intensive experiments to practical engineering. Subscribe to our channel to continue exploring the frontier of materials science. Thank you for watching.